Hello, everybody, and welcome to the first in a series of workshop/courses that are going to be going for the next 4 weeks. They'll be going at this same time every Tuesday and Thursday. There'll be a total of 8 sessions, and today's session is mostly going to be about, well, what this course is about. There'll be a bit of review for people who might be already familiar with some rendering and materials stuff, and I'll basically just be giving an overview of what's going to be happening, and with that in mind, this is probably going to be the shortest of the of these streams slash workshops. The next workshop on Thursday is probably going to be a bit longer, and now I'm just going to go through basically a list of things that I'm planning on talking about for each session. While you guys look at this nice green head, or maybe even this guy right here. So as I said before, this first session is sort of an introduction and overview of physically based rendering, how it's different from other types of rendering, and some of the effects that you can get with it. During this first session, I'm basically just going to be talking about the most basic stuff that you'll ever see in physically based rendering. You know, Albedo / Diffuse, Specular, normal maps. I'm also going to just barely touch, at least for this first session, on skin shading and different applications for it and different ways that you can use it. All the stuff that goes into modern skin shading, and how different skin shaders in different programs tend to work. I'm also going to be just listing off the basically for each session what I'm going to be doing in that session. So I'm gonna start with that now. I'm gonna start with the list of things that I'm going to be talking about beyond session 1. So for session 2 on Thursday, I'm going to be talking about albedo maps, diffuse shading, and texture file formats. Now, a lot of this stuff it's kind of the boring stuff. It's the stuff that is not very glamorous at all, but it is a lot of stuff that's important to know if you want to work in a game dev studio, if you want to make sure that your work is able to ship, if you want to make sure that you know, your textures don't look pixelated and gross, that's something that's very important to know. Texture formats, compression, learning how MIP maps work, learning about how things like 8-bit and 1-bit alpha work, and file formats. As far as albedo and diffuse shading go, I'm going to be talking about what albedo actually is in comparison to things like, you know, specular or other types of shading. I'm going to be talking about how albedo is different from diffuse shading. I'm going to be talking about what diffuse shading is and how it's different than albedo and how it's different from specular. I'll be talking about things like energy conservation and how it affects diffuse color and specular color. I'll be talking about what energy conservation actually is and how it will affect you. Additionally, I'm going to get into a little bit of how you can author different types of albedo maps. I'll talk about using albedo and specular together, using albedo and ambient occlusion together, because albedo and ambient occlusion, or diffuse and ambient occlusion, previously had often been combined into a single texture, but now that we have more advanced rendering capabilities, you actually will tend to split them out into separate maps that the game engine you're using will sort of process differently from each other. I've got an occlusion map right here, and you can just see a little bit of how it's affecting the shading in the crevices. I'll talk about how that works as a post-process, how it can work by being integrated into textures. I'm going to be talking about using albedo or diffuse and normal maps, how normal maps actually affect well, how things work, how things look, how it affects things without affecting specular, or how it does affect specular, how normal maps also affect diffusion for subsurface scattering in skin. You can see a little bit of that right here. If I play with this slider in Marmoset Toolbag, it'll actually smooth out the results of the normal map. So that's one area that I'm going to be touching on. Additionally, I'm going to be talking a little bit, not too much, but a little bit about acquiring information for albedo textures, not just in the sense that you're painting something in Photoshop or in Substance Painter or whatever, but also in ways that you can acquire things from the real world by taking pictures, or by going online and using different resources and such. I'm going to be talking about, as I mentioned before, different file formats for textures. This is very important when you're talking about using, say, normal maps, because different file formats, different formats of normal map information are processed differently. Then in week 2, I'm going to be talking about specular and gloss maps and normal maps. Specular and gloss is going to be one session, and normal maps are going to be the next. Here, let me just bring this over onto here so you can actually see the schedule. So here's week 2. And so I'm going to be talking about, what exactly is specular? How does it work? And how is it different from, say, metalness? I'm going to be talking about gloss and how gloss and specular are often used together, and metalness and roughness are used together. Why that happens, how metalness and roughness works, what's the same between them, and the different ways that they can be either combined or work together. I'm going to be talking about colored versus white specular, or gray specular. Once again, I'll be touching on energy conservation, and that'll be a little bit of a review along with some additional information for people who might not have been there, or people who want to learn a little more. I'll be talking about Fresnel, and how Fresnel is not just how to add glowy edges to your character, but it's actually a property of physically based shading, of how shading works in the real world, and how it affects things like, well, if you have a shiny surface, the edges tend to be a lot shinier, and often they'll get glossier. I'll talk about why that happens, how that works. I'm going to be talking about some special types of specular, such as anisotropic specular, which if you know what anisotropic means, or if you don't, anisotropic means that it is not the same in all directions. So anisotropic specular, you'll often see it being used on hair. I can show you an example of that right now. So you'll notice on this guy's hair, he has a banded specular, specular highlight. If I come in here, I can turn down that effect and push it more towards the round specular highlight that you're used to using. Anisotropic specular is absolutely fantastic for things like hair, brushed metal, and other similar surfaces that have lots of little lines next to each other that are too small to get into your normal map or into the model itself. So I'll be talking about how that works, why it works, and some applications of it in the real world. Overwatch uses anisotropic specular to great effect for almost every single one of its characters, and I'll show you how that works and how you can apply it to your models. I'm going to be talking about how the spec and gloss workflow is different from the metallic roughness workflow, and really how they're actually the same thing, just with slightly different directions that they're coming from to achieve the same end result. I'm going to be talking about how specular and gloss maps are authored, how they're different, and I'm going to be talking about how metalness and roughness maps are authored, and how each one works together. I'll also be touching on a few other smaller topics, such as making sure that you don't get artifacts in your textures. And then for session 4, the normal maps session, I'm going to be talking about a lot. This list that I have right here seems fairly short, but there's a ton of information for each one of these bullet points. I'm going to be talking about the very basics of what normal maps are. I'm going to be talking about how polygons are represented in 3D space and how normal maps affect that. I'm going to be talking about how normal maps work and what the different channels in a normal map affect. I'll talk about tangent space normals, object space normals, how they're different, how they're similar, how one can be converted to the other. I'm going to talk a little bit about how normal maps are authored. I won't spend too much time on that, mostly because authoring normal maps is something that's been sort of done to death. So I'm basically just going to touch on it, say here's some resources that you can use. And then finally I'm going to be talking about some special ways that I like to author normal maps. Additionally, I'm going to be talking about something called swizzling. It's a pretty silly term, but it has to do with the different color channels of the normal map and how they relate to different directions in 3D space, whether it's in reference to the surface of the model or in reference to absolute 3D coordinates. I'll talk a little bit about using object space and tangent space normal maps. In general, most people won't be using object space normal maps in a final game these days, but you do occasionally see it, so it's good to know when and where you should use them, and when and where one could or should be converted to the other. I'll also go over some baking tricks that make it easy to take complex geometry and bake it down in ways that working with cages and cage baking doesn't usually work out very well. So that's when object space normal maps come into play. I'll talk a bit about using hard and soft edges with normal maps. This is actually a pretty big topic because it relates very strongly to hard surface work, and given the current state of the game industry and games that people are working on, games that I'm working on, that type of thing, making sure that you know where to use hard and soft edges is very important, because the way that your model smooths out and is shaded can be drastically different based on different factors relating to the smoothing of the model, the smoothing of the high poly source, the smoothing of the normal map, etc., etc., etc. I'm also going to talk about triangulation, why triangulation is important, and how it affects shading with normal maps. I'm also going to talk about how normal maps should be baked and should be applied to a model, and how triangulation will affect that. It basically boils down to, if you have bad triangulation, you're not going to have a good normal map. But there's a lot more to talk about aside from that. I'm going to be talking a little bit about bent normal maps and how they're used. You guys may have run into people talking about bent normal maps before, and initially they seem very, very similar to object space normal maps, but I'm going to be giving some examples of how you can use them for things aside from baking them out and then stealing one of the channels to use in your hand-painted textures. They're actually very useful for things like skin shading, and they can occasionally be useful for hard surface models, although in general it's not very useful unless the hard surface model or any other model has very, very tight details on it. Finally, I'm going to be talking about bit depth for normal maps, what that means, and how it affects the final results. That's actually going to be a bit of review from session 2, where I talk about compression, bitmaps, and different file formats. But there's some specific stuff that you want to keep in mind for normal maps so that you know you're getting the best results possible. For week 3, I'm going to be talking a little bit about baking in UVs for session 5. There are some specific things to worry about when UV mapping for characters, especially given current generation limitations and the ability to use very advanced shaders. Placement of seams along with UV island orientation are both very, very important things for getting consistent, high-quality results for things like clothing, tiling textures, and any other similar things you might be worried about. I'll talk a little bit about good UV layouts for character heads, hands, and that type of thing. And I'll also touch on best practices for laying out clothing and shoes and other things that you'll probably run into as you're working on games in a professional setting. I've got a question from Dylan. He's asking if there's anywhere that we can get a copy of this curriculum. I will be blasting links out to downloads for the public, but I'll also be giving program members special access to example content and other such, stuff that I'm working on that I'm going to be showing. Program members will actually be able to download all the content that I am using, but everybody in general will be able to get a copy of this schedule. I'll put it up on the Patreon page, and I'll post links to it on Twitter and Facebook and all kinds of other places. So don't worry about that too much. I'll make sure to have this stuff out there in the public available so that you guys can just take a look at it. Let's see here. I'm going to be talking a bit about relaxed versus straightened UVs. This is something that might seem like a little bit of a weird topic because it seems fairly minor, but when it comes to doing UV maps for clothing, this is super important because if you have highly deformed clothing, straightening versus relaxing your UVs can have a huge effect on things like tiling textures. And I'm going to give some examples of how to best do that and some use cases where straightened UVs, say a straightened belt line for a character, is best versus just relaxing the thing. I'm going to be talking about the 0 to 1 UV space and what that actually means. I'll be talking about how it can be used in baking, how it can be used to exclude things from baking, and I'm going to be talking about how this is important for things like Substance Painter, where you might not really get perfect bakes if things are inside or outside the 0 to 1 UV space. I'm going to be doing a little bit of information about overlapping UV sets, along with baking with overlapped and offset UVs. That's a it's a weird topic to cover because each program handles things differently. And some programs like Marmoset Toolbag, they don't really like mirrored UVs that are along, say, the center of a character's head, because they might introduce artifacts. So I'll go over different uses and problems you might run into for that. And then finally, I'm going to be talking about UV island spacing versus texture resolution, and how, if you've been doing any sort of game art for a while, you might have run into situations where everybody told you pack your UVs as tightly as possible, but you might find at some point these days that that's just simply not the case. You sometimes don't want to pack things as tightly as possible because of, once again, going back to session 2, mipmaps and compression. There's a lot of stuff to cover there, so I'm not gonna dive in right now. For session 6, I'm going to be talking about types of shaders. What the hell is a shader? I mean, what does that mean for you or me or any game artist, anybody who is not a shader artist, anybody who's not a tech artist? What is a shader for me, and how does it relate to what I'm doing? And then I'm going to be going over different types of shaders, different basic shaders for common materials like metal, plastic, wood, and how they all relate to each other, and how often they can have, just the same shader. I'm going to be talking about more specialized shaders for things like skin, hair, refraction, and cloth. And I'm going to be touching on energy conservation again, what that means for skin shading. If you've ever tried to go into Marmoset Toolbag and play around with their skin shader, you might have run into situations where, you know, if you have a nice warm color in the scatter, you just end up with like odd colors in there. And sometimes you find yourself wanting to get like a blue translucency, but it turns out yellow. I'm going to explain sort of why that happens and how to avoid that, along with ways that you can use that to your advantage. I'm going to touch on the importance of screen and world scale with specialized shaders. So this, once again, comes back to things like skin shading. If your model is not the right scale, sometimes skin shading just simply won't work out. This tends to go for a lot of modern skin shading techniques. A lot of them are based on what is actually on the screen, as opposed to, you know, how big the model is or anything like that. And other times they're based on the scale of the object in the world. And those things can have a massive effect on the final product that you're looking at. I'm going to look at other special case shaders like cell shading, parallax mapping, displacement, tessellation. For this session, I'm actually going to be jumping into Unreal 4 a bit, putting together some very simple shaders and showing basic construction of some of them. And I'm also going to be talking about screen space shaders, screen space shading, post effects, outlines, cell shading, etc. I'll make sure to provide resources for where you can look up how to do effective cell shading as a post process, as opposed to cell shading as a shader on a character. And then in week 4, I'm going to be talking about I'm going to be starting to talk more about rendering as opposed to materials. For session 7, I'm going to be talking about principles of lighting, the types of lighting you'll run into and the types of lights. You know, there are different types of lighting, both ambient and directional. These come from, say, image-based lighting, along with lights that you might place in a scene. There are different types of lights as well. There's not just like one type of light that you could, you know, drag around in a scene that you're working on. There are directional lights that affect the entire scene. There are spotlights, which are similar to directional lights, but not quite. What does that mean? And there are omni lights, which shoot light in all directions, but they have some strong limitations. I'm going to be talking about some specific terminology related to lighting, such as key lighting, rim lighting, fill lighting, how those things work together. I'm going to be touching on image-based lighting and how it affects your character, and how it affects the overall mood of a scene. I'll talk about how and when you might want to or not want to use strongly colored lighting for whatever it is that you're working on. And I'm going to be giving some examples of very basic lighting setups specifically for characters to present characters in the best way possible. I'm going to talk about the difference between lighting characters for still renders, as opposed to real-time presentation, and I'm going to be giving some tricks that you can use for real-time presentation, say, on the web. So if you wanted to present something in, say, Marmoset Viewer or Sketchfab, I'm going to be giving some examples of, you know, best practices that you can use so that your character will always look good no matter what angle you're looking at it from. So for session 8, session 8 is going to be the final session where I'm talking about anything, and it's mainly going to be concerned with post effects, rendering, and for this session, if I have time for it, I'm actually going to light a character from start to finish, apply a bunch of post effects to it, and come up with essentially a final render. If I don't have time for it, I'll just go over what's on this list. And Basically, what I'm going to be going over is the types of post effects that you run into, both in things like, Marmoset Toolbag, where you have different options under rendering and your camera stuff, and and how those are similar to things in, say, Unreal 4, Unity, or proprietary engines that you might see at some job that you might get. I'm definitely going to be talking about different camera settings and how those affect presentation of characters. You'll notice that the first one on this list is field of view, and field of view is one of the things that has the strongest effect on how people perceive your character, because it can make it look like a nice, attractive portrait, or it can make it look like a creepy, awful Godzilla monster that's coming to eat your face. And we don't want creepy, awful Godzilla monsters unless you're making a creepy, awful Godzilla monster. I'm going to be talking about depth of field, how depth of field interacts with transparency, and how it interacts with, additive transparency, how these things work together, how different post effects are sort of layered on top of each other in a render to achieve certain effects, and how you can avoid getting artifacts in your renders. I'm going to talk about chromatic aberration, which is always everybody's favorite little conversation. I'm going to be talking about lens flares, different ways to achieve them, different ways to fake them, different ways that you can get them in your scenes or not get them in your scenes. I'm going to touch on things like barrel distortion or fisheye distortion, where it's probably best to use it or avoid it, very similarly to field of view. I'm also going to be talking about post effects like tone mapping and levels adjustments. These are really great ways to make sure that your character pops out of their environment really strongly, and they're presented in the best light possible. You're probably not going to go out and take a photo and then just dump it straight from your camera onto the internet or into a gallery or something without doing some levels adjustments. And certainly you shouldn't be doing that with characters. I'm going to talk about bloom and how it works, not just in the sense that, it makes stuff kind of glowy, but how it works in a slightly more technical sense so that you can use it to your advantage with things like 32-bit textures that have self-illumination. I'm going to talk about Vignette, and once again, best times that you would want to use it, along with film grain. And then I'm going to be touching on a little bit of stuff that you mainly will see in things like Unreal Engine 4 with color lookup tables and what exactly those mean. And then I'm going to just sort of dabble in a couple of other miscellaneous post effects, just talking about different things you'll see in different programs, the differences between things like Unity, Unreal 4, Marmoset, Sketchfab, and any number of other programs you might see that use advanced post effects. Then I'll be talking about some of the more nitty-gritty things like screen space reflections, ambient occlusion, and global illumination. Screen space reflections are something that until recently it wasn't possible to do in real time, so that's a really nice thing to add to your renders if you're whether you're in Unreal 4 or Unity or Marmoset, whatever. There are one more way to ground your character in a scene and ground the details of the character in the character for, teeth and eyeballs. I'm going to talk about ambient occlusion, how it works, what it means to you as a character artist, how it will affect your final renders. I'm going to talk a little bit more about how baked ambient occlusion affects what you're making. And then finally I'm going to stop on global illumination and bounce lighting and how that affects all of these other different lighting and rendering options that you have. There's a lot to cover in global illumination. I'm sure most of you will have heard a bit about it before, but I just want to make sure that the groundwork is there. I'll be talking about different implementations of global illumination, including the ones in Marmoset Toolbag, and ones that are either in development or currently out for things like Unreal 4 and Unity. I'm probably not going to be doing too much in Unreal 4 or Unity, since in general those tend to be either baked global illumination for game levels. But it's still something that's important to understand, especially when we go back to talking about things like image-based lighting, because often global illumination and image-based lighting work together very closely, especially in modern shading and rendering for current generation games. So now that I have the basic schedule and topics out of the way, I'm just going to take maybe a half hour to talk about this scene that I have right here, touch upon all the different types of textures that I'm using, where I'm using different types of shaders. I'm going to talk a little bit about each of the different parts for this character. I'm going to talk about how I lit this character, different ways that I was able to texture different parts of him, and just give a general, very basic overview of each of the different textures and shaders that I'm using. And then I'm probably going to end this first session a little bit early and dip out so that I can talk to the program members. But I'm definitely going to be making sure that I'm paying attention to the Twitch chat and the chat channel that I have for the program members, in case there are any questions or anything that anybody would like to know about a specific thing that I'm looking at that doesn't seem like it was mentioned in the schedule and topics overview. So this is a character that I made a year or two ago now for the guys at Marmoset, because they wanted some example content to show off at GDC. And the general idea was that they wanted a character with a lot of personality that showed off a lot of different types of materials. So I thought, okay, yeah, I'll make this rock and roll dude that I've been thinking about anyway, and so I got started. The general idea for this guy was that he would be able to be lit in many different types of lighting scenarios and rendered in lots of different types of ways, and that he would show off good material definition. So what do I mean by material definition exactly? Because this is something that I'm going to be mentioning a lot in the coming weeks, and it's important to have an understanding of what that means before I start babbling endlessly about it. Material definition is really basically just an understanding of how two materials that are next to each other are different, and using that difference to accentuate the fact that one material is its own material and the other material is a very different material. So an example of that you can see is on the shirt here. The shirt very clearly has a slight fuzz to it, and it's just flat. It's kind of a flat color. You can't see any highlights on it. It's very smooth. And that is basically meant to simulate the look of sort of like cartoony cloth. A nice soft cloth like you'd see on a t-shirt. By contrast, the leather vest right next to it has much tighter specular reflections, along with this tiling leather pattern, and around the edges of the vest you can just barely make out a little bit of rougher patches. The reason that I chose to do a leather vest as opposed to something like denim is because I knew that having this highlight right here on the leather vest would make the fact that this shirt is much more dull, well, it'd make it much more apparent. So by having something that's very dull next to something that's kind of shiny and very textured, it's automatically accentuating the differences between those two. So that's what I talk about, or that's what I mean when I talk about material definition. Now you can see something similar with this hand and the body of the guitar and the neck of the guitar. The hand very clearly is meant to be some sort of, flesh. It has some broad specular highlights and a nice kind of pinky tone to it, whereas the guitar is very clearly made out of an artificial material with, it has fleck paint, it has different specular colors, it's very highly reflective, it's very glossy. Once again, this is an example of the material definition that I'm talking about. If you only have one thing in a scene, for example, this nice green head that looks like it's made of wax or jade or something, you don't really get material definition, you just get sort of a material. You get the idea of a general material. But if suddenly, let me duplicate this real quick. I'll just duplicate this and scooch it over and make a new material. If I duplicate this head, make a new material, and plop that new material on it, suddenly the highlights, the subsurface scattering, the shadows, and the image-based reflections that you can see, they all sort of pop out a little more because you have some contrast with it. Let's make this even more different. Let's turn down the gloss as low as it will go. Turn it to a different color. Let's go with a nice purplish color. A little desaturated there. There we go. That's good. Let's change this to microfiber, if it will let me and not freeze. There we go. And then, yeah, we'll crank up the fuzz on this. Change that to a slightly purple-pink color. And now, by having these two things next to each other, suddenly you have much stronger material definition. If we just look at this purple one on its own, I mean, it looks like kind of this weird purplish material, sort of, but I mean, what is it supposed to be? But then when you place it next to something that has very strong reflections and a very different way that the light scatters through it, suddenly it starts to look almost like cloth or some other similar type of soft material, maybe a soft touch plastic like you might see on certain types of phone cases. This fuzziness is starting to look like it's catching the light at glancing angles in a way that's very different from the way that light's catching right over here. So naturally, having these things next to each other introduces material definition into the scene. It introduces it into what you're looking at. And like I said before, material definition is one of the things that I'm just going to be harping on constantly over the next 4 weeks, because it's really what making characters is all about. Making materials for characters is all about. If you don't have good material definition on your characters, they're all just going to kind of look like plastic or something, and nobody wants that. So by making sure that your materials have very good definition, they have very strong differences between the different materials, even if one material on its own is not so hot, by contrast, it's going to look great next to the other materials next to it because it's so different. It will automatically look better once it's next to a different type of material. So let's look at some of these different types of materials. Let's look at, let's look at the clothes for now. Let's look at the clothing. So here we have our clothing material, and this is very similar to a material that you might see in Unreal 4, Unity, or any other sort of physically based rendering program. And I mean, even programs that aren't physically based, it's still possible to get this type of material definition. It's just, it can sometimes be a little harder. So for his clothing, and let's just turn everything else off. Let's turn off his guitar, the amp, the floor, the chords. pick. Let's turn off his head and his skin, his eyes. Let's just turn all this extraneous crap off so we can just take a look at his clothes. So these clothes are just using a single shader. But I've been able to get nice material definition on this shader by doing a few different things. First, for things like the cuffs, I've made sure that there is a difference in the specular value of the cuff itself versus the studs on the cuff. So the studs on the cuff have a very high specular value, which, if you turned it down, would make them look like plastic. So let's try that. If we turn the... oh, looks like they're using a metalness map, but the point remains the same. And actually, that's going to be a little more useful for us right now if I want to demonstrate the difference between reflective and non-reflective. Oh, Dylan's got another question. He says, are reflections the only way or the best way to create contrast and material definition? And that's an excellent question. That's a great question to ask, especially in light of what I'm looking at right now. The answer to that is obviously no. At least for me, it's obvious. But if you look at something like this, you'll see that even though these two materials have very similar specular values, here you can see the specular value of this one is 0.2, and this one is also very low. It's 0.087. If I turn these two, well, both to 0.4, you'll see that they still look very, very different. So specular or reflections, they're not really the one and only or best way to get material definition, but they are a key way of doing it. There are lots of ways that you can get good material definition, but actually probably the best way is through the use of gloss. So gloss and specular are tied very closely together, and gloss, in case you're unfamiliar with how physically based rendering works, or just rendering in general, if you're unfamiliar with how it works, basically the specular reflections are the environment and the lights being reflected off of your model, and the gloss is how tight those reflections are. So with a very, very glossy surface, this starts to look very smooth. Whereas the thing next to it, it doesn't have a very glossy surface, but it still has the same specular value. So just the gloss value alone is enough to differentiate these two. Here, let me show you an example with the same material, except one of them has a high gloss and one of them has a low gloss. Let's just duplicate this material, turn the gloss down, and slap it on here. So this is an identical material, and the only difference whatsoever is the gloss. So the way that you view gloss, the way that gloss is represented on your model, that's one of the key factors in making sure that you have good material definition. In general, when you're looking at physically based rendering, most objects are going to have the same specular value, and I'm going to get to that later on once we discuss specular, but it's good to cover right now just to lay the groundwork. On average, most materials that you see in everyday life, whether it's glass or wood or plastic, they all have roughly the same specular value. Now on a linear scale, from 0 specular to 100% specular, or 0 reflectivity to 100% reflectivity, most objects will only reflect, at least as specular light, as these sort of mirror-like reflections, they will only reflect 4% of light that hits them back as those types of reflections. Now I'm going to be talking a little bit about energy conservation and what that means for things like gloss later on, but that's something that's that might be good to keep in mind for later. Sort of ask, hey, what is energy conservation? What, how is that going to affect this? I'll explain that. I'll explain exactly what energy conservation is, but the general gist of it is that energy conservation means that if some light hits the surface, say this nice highlight right here on his forehead, if light is hitting this surface right here, and the same amount of light is hitting the surface right here, well, energy conservation says that this same amount of light will be reflected. It'll just be reflected over a wider area, so it'll kind of smear around and be darker the more, the lower gloss value you have. So as you can see, as I crank up the gloss on this guy, that reflection gets tighter and tighter, and all of the highlights from certain areas that are away from the light start to get a little bit darker. So there's more to energy conservation than that, and I'll get into it in a later session, but that's the general gist of it. Energy conservation means that highlights get dimmer as the gloss gets lower. So other good ways of getting material definition obviously have to do with, changing the surface color of what you're working on. Oh, clearly these are two different materials now because one of them is blue and one of them is green. But there are other ways of getting good material definition as well. For example, if I wanted this to look like it is covered in thousands and thousands of teeny tiny little hairs, like you might see on somebody's skin, I can introduce a Fresnel fuzz term onto there. I could break that up with a texture that has lots of tiny little hairs on it, but this might be pretty good if I wanted to do some sort of, like, I don't know, alien skin or something. There we go. He has sort of alien-ish skin now. He's a little bit fuzzy. He's one of those blue guys from Star Trek. All right, so that's a little bit about material definition and how that can work for things that are next to each other. But how can you define materials when you only have one material? Well, the answer is by not just varying your gloss map, but by varying your specular as well. So since this entire body only has a single shader on it, right here, it says clothes, there's a few things that I need to do to make sure that different parts of him actually read as being made of different materials. One of these things is by adding that fuzz term. So you can see here that his boots are made of two different materials. They have some metal, which is highly reflective, but not very glossy. And then his pants are, they're not glossy at all, but they do have that sort of fuzz around the edges. And here, I can turn that down. Now, in most programs that you're going to be seeing, in most programs you'll work with, they'll have some sort of cloth shader or the equivalent of a cloth shader or something where you can get some nice fuzzy effects around the edges, and you can turn that down, turn it up. And in the case of what I'm working on now, with these different materials on the same shader, I can mask the fuzz with gloss. So this is something that's specific to Marmoset Toolbag, but you'll see other similar options in things like Unreal 4 or custom-built Unity shaders. These are pretty common options when somebody wants to represent cloth. So let's look at some of the other materials. Let's turn his head back on, along with the eyes. So his head, as you can probably guess, it has a skin shader on it. The skin shader, we've taken a look at it a little bit before. I'm not going to get into it too much. So let's hide that head again, actually. Let's just take a look at his eyes. His eyes have a few different things going on, and I'm going to touch on some of these later on when we talk about more specialized shaders. But I just want to, give a little bit of a sneak preview, a sneak peek of some of the things that you can do with specialized shaders so that you know what's possible and what we're going to be getting into. So let's look at eyes. Eyes are a pretty interesting topic because they have multiple different materials as a single object. They have the sclera, which is the white. They have the iris, which is the colored bit. They have the pupil, and then they have a lens. So the lens is this clear part that goes over the entire iris right here, and then it just kind of blends into a sort of glassy covering along the sclera. Well, that's great, but it's also very difficult to get all of that into a single model, a single shader. So what I've actually done here is I've made the eyes in two separate pieces each. One part is the inside of the eye. It doesn't have any reflections on it. It's just diffuse shading and a little something to make it look like it's refractive. So this is Parallax Mapping. Let me see if I can pull it out in here. We've got, let's see here, there we go. So here is the shader for the eyes. It has an albedo or diffuse map. It's got a normal map to get the nice shading on the underside of the iris right here. And then it has a height map. If I turn off the height map and turn the depth down, you can see that these are really just balls. Well, half balls. But if I turn the height map on and turn the depth up, it suddenly starts looking like the irises actually punch back into the eye. And when we come at it from a glancing angle, even though the geometry hasn't changed, it looks like there's depth to it, and it looks like it's refracting. So that's one more way that you can get material definition. Not just by having different colors or different specular or gloss values, but by having things like parallax mapping. So that looks kind of refractive, but eyes just aren't the same if they don't have something sort of glossy on them. So what can you do to fix that? Well, there's a few different ways that you could do it. One is to have a specialized shader that goes across the entire surface and ignores the normal map of the iris and the height map of the iris. But a much easier, much cheaper, and much faster way to do it is to just create a shell around the eye. And here you can just barely see the shell. Let me turn on wireframes, and you can see, oh, well, I just have some duplicates of the eyes that have been pushed out a little bit. They're a little bit shiny. They go over the surface of the eye. And these are actually in Additive Transparency mode, which is something that you'll find in a lot of different programs, a lot of different game engines. And this is something that we're actually using on Spider-Man PS4. It's a pretty widely known technique. It's really easy to implement, and it's great for production because it's very fast and very easy to understand. So you have the base eyes and the eye shells. The eye shells are the only part that's reflective, and you can see as you get closer that they reflect the environment very nicely. They look great. Now, Additive Transparency has a few different options in basically anything that you'll be any game engine you'll be looking at, and there's also ways to do it with custom shaders. But in Marmoset Toolbag, it has options for tinting. It has options for including a diffuse color, so you can actually get, say, a vase that has a green tint to it, or some fire that's added on top of the rest of the scene. Depending upon what type of shader you're using, the Additive Transparency might take into account things like the specular map, which it's doing right now, or the color map, normal maps, any number of different things. There are a lot of ways of using Additive Transparency, and I'll be talking about this a little more as we get deeper into this program. So let's talk about the hair. I know I mentioned the hair before a while ago. I mentioned the anisotropic specular, so let's look at what that means. Let's move the light so that we can get a little bit better highlight on it. That's good. Okay, so let me turn off the wireframe, and here we have some pretty basic cartoony hair. It's cool. It kind of gets the job done. It's got a little bit of texture to it, but you'll notice in looking at this that it doesn't really look like hair. It looks like a plastic shell. This is something where later on, once I'm talking about specular, I'll get a little deeper into this, a little bit deeper into the techniques that I use for this. But for now, I'm going to just show how the anisotropic specular affects what you're looking at here. So let's go to the hair shader right here. So you'll see in this shader, I have a normal map, just like you'd expect in any other shader. I have a gloss map, I have an albedo or diffuse map. I have a little bit of subsurface scattering to get some nice translucent hair feeling to it. But the really important part about doing hair is anisotropic specular, which stretches out the highlight along a certain axis of the UV map. I actually have two anisotropic highlights on here, which I'll explain how to why I'm using those a little bit later. But the general gist is that if you're not using anisotropic specular, well, it just kind of looks like a plastic shell. But then suddenly, once you turn it on, wow, it looks like a bunch of strands next to each other. You know, it's controlled by the gloss map. Having multiple anisotropic highlights can have great effects for adding more translucency feeling to it. And just in general, this is one great way that you can add some interest to a character's hair. And like I mentioned much earlier, anisotropic specular is used pretty widely for hair. You'll see it in most current generation games that are trying to get a hair shader. And there's a very great example of it in the form of basically anything that you might see in Overwatch. Almost every single character in Overwatch has hair, aside from the robots, and the characters that do have hair have some really great anisotropic highlights on their hair. It's this neat stylized band, and I can show how to get very similar effects using something called a flow map or an anisotropic direction map. Once again, that's something I'll probably cover in the specular discussion, but it's important to know that it's here now, so that you can look forward to it later, you can investigate it on your own, and you know, just so that you can check it out later on. Now, what else do we have to look at here? Well, we have the guitar. The guitar is pretty cool, so let's take a look at the guitar. It's got that metal flake stuff going on, so let's turn that on and take a look at it. So there are a couple of different aspects to this guitar. One of them is the red paint of the guitar, and one of them is all the little hardware bits. So all the hardware is on its own shader right here, and all this red paint with all these little metal flakes, this is on its own shader. So I separated these out into two different shaders, mainly because it made it easier to get a very wide range of gloss colors and specular colors and levels of gloss highlights. You really could combine these into two if you wanted to, but I just didn't feel like putting in all the effort for it, because really this is mainly going to be used for portfolio presentation and in stills, so it's not something you need to worry about. If you're in production, depending upon what you're looking at, if it's a hero asset or something that's going to be in the background, the restrictions might be a little bit different. But let's take a look at this guitar paint. It's actually fairly simple. And there are some things in here that I'll be covering in the specular discussion, especially having to do with the average level of specular you might see on everyday objects, as well as just talking about specular color. So here you can see, as I zoom in a lot farther, that the metal flake texture on this guitar is actually pretty pixelated when you get up close. So it's not actually a very specialized shader. It's not something that needs a lot of like specialized programming or anything. It's really just a pretty high resolution texture. So that high resolution texture is this specular map right here. And you can see, well, you might be able to see, depending upon the resolution of the Twitch stream. But you should be able to see at least a little bit of noise in here. And really, it's just RGB noise that's been made in Photoshop using some filters. It's on a gray background because I want the reflections to just look like paint. So it has a very plain base specular color. And then all that noise introduces some different specular levels and specular colors to make it look like light is reflecting off of little metal flakes that are embedded in the paint in a clear coat. It's a pretty simple process to use. Now, in addition to that, I have a secondary reflection set up so that it adds just a tint of blue. I like adding a tint of blue or some other bright color to things that are supposed to look like sort of metal flake or car paint because it makes it look like that it has lacquer or shellac or something over the top of the paint. It's a neat little effect that just adds a little bit of believability to it. Just adds a little punch on top. Now the rest of the guitar is actually fairly boring. It doesn't have anything terribly unique going on. It just has a single specular color. It does have a detail normal map for a little bit of tape on the back that has a cloth texture. Let's see if we can highlight that just a little bit. Yeah, there you can see just a bit of that texture right there. But that's been masked off in the detail weight map, so it's only on that little bit of paint or that little bit of tape back there. All the rest is just using a metalness shader so that the bits that are metal look like metal and the bits that aren't look like plastic or paint or anodized metal or whatever other materials I have there. So that's a pretty basic overview of what I have in this scene. I have a bunch of different shaders that all add up to something that looks like a character with fairly believable, if not completely realistic, shaders and presentation. Oop, let's make sure that we can see his skin. There we go. Alrighty. So, there's a general overview of what this workshop is going to contain. There's a very basic overview of the types of things that I'm going to be covering, along with a concrete example of the types of things that I'm going to be talking about in the context of characters and how characters work with materials and rendering. I'm not going to get into any more of the rendering and material stuff tonight, and I am going to end it a bit early, like I mentioned earlier, because I don't have a ton of stuff that I want to cover tonight. I want to push some of that onto Thursday so that it's a more focused discussion. But I am going to stick around for about 5 more minutes, just to make sure that I've got all my housekeeping done. And if anybody has any questions before I go, feel free to ask now. Otherwise, in about 5 minutes, I'm going to be taking off and going to the private chat session with the program members, where we can talk about the next steps that we're going to be taking. So thanks for tuning in. If you have any questions, please feel free to put them in the Twitch chat now. And if you don't have any questions, thank you for dropping by, and tell your friends that this is happening. The first 2 hours of every single session will be free for anybody to watch, and then after that I'll cut off the Twitch stream and go to a private chat session with the program members. This will be continuing for the next 4 weeks, and the next session is going to be all about albedo maps, diffuse shading, and texture file formats, and why those things are important for artists who are getting into production, or artists who are, well, just wanting to get into character art and rendering. Alrighty, I'm going to be shutting down the stream in just a second here. So thank you all for coming by. It's been a pleasure, and I hope that you guys will stop by again on Thursday at 7 p.m. Pacific time to catch session 2, talking about albedo maps, diffuse shading, texture file formats, and more. So have a good night, and I'm going to be switching over to the private chat now. So have a good one.